Hi everybody, this is Mr. Folly, and we're going to go through a quick video without windy sounds, so you can hear and see what the parts of the periodic table look like. So let's hop to it. We're going to identify families. Okay, so families and then groups. And I don't know that this is even all that real, but a group is a number and a family is a name. So we'll go through that pretty quickly. So here's our periodic table and the functional parts. So families, S and P are named. So I'm going to zoom out of this a little bit. So what that means is this family right here, whoops, come on, let me write. This family right here is the alkali metals. This family right here is the alkaline earth metals. Oops, it looks like Urch. It's Earth, like our planet. And oh no, why can't I write the word Earth? E-A-R-T-H, metals. And then I'm going to highlight this part. Oop, oh, probably not. There we go. And this part right here, these guys right here, they're not really a column, so they're not really a family, but it is okay to call them the, oh, I'm going to make this bigger. If my pen will let me, it won't. So I'll go to, well, maybe I'll make it bigger. Nope. Oh, well. So this is called the transition metals. I'll label it in there because you can't see it. Transition metals. And then I get over here. Over here, it's pretty easy to name them. It's the boron group. It's the carbon group. Hey, how can you see that? It's the name of the top one. It's the nitrogen group. It's the oxygen group. And then it's weird. It's not the fluorine group. It's the halogen group. And then it's the noble gases. On this part down here, I wish I could change my color, but my little computer thing's in just the wrong spot. These are the inner, I-N-N-E-R, not inter, transition metals. So again, this is the alkali metals, alkaline earth metals in that column. Boron group, carbon group, nitrogen group. And remember, that would be alkali metals would be all of these. Alkaline earth would be all of these. Okay, and then the other ones are grouped like that. So the alkali metals are reactive. They're large. They have one valence electron. Those are how you describe them. Group 2 is the alkaline earth metals. They have 2 valence electrons. 3 is the boron group. Notice we skipped the D block, which we call the transition metals with 3 valence. Carbon group has non-metals and some metals, right? 4 valence. Nitrogen group, 5 valence. Oxygen group, 6 valence. Halogens, most reactive non-metal, 7 valence. Noble gas is unreactive, 8 valence. So we got some things that we're pretty used to here. Hydrogen is its only family. I'm sorry, is its own family, not its only family. It's a non-metal, has 1 valence electron. This is often forgotten. Don't forget that, because hydrogen is not a metal. The charges are periodic as well. We've seen this before, but we'll show it again. +1, +2, +3, 0, -3, -2, -1, 0. So everything in that column has that charge. So what's strontium's charge? +2. What's sulfur's charge? -2. What's gallium's charge? +3. These guys in the middle are unknown. So we have to give more information. These guys do. We don't do much with the F block besides forget about it. The F block for us is like, forget about it. All right, so I'm going to try even harder to move my, there we go. So I'm going to change my color a little bit. No, it's not going to let me do that. I tried my bestest. So I'm going to make a stair step, which you should make in yours too. And in this stair step, well, maybe I will be able to change my highlighted stuff. So we'll make our metals light blue. So everything I'm coloring in here is a metal. Whee! Okay, so everything is colored in here as a metal. Notice I didn't color in hydrogen. And here are my metals. Okay, I'm going to color in my metalloids. I'm just going to shade these in black. Notice how they have 2 sides on that stair step. Okay, so there's my metalloids. And then I have non-metals, which, oh, let's make them pink. Isn't that pretty? Non-metals are here. Now notice anything with 2 sides on the stair step I said was a metal, metalloid or a semi-metal. The exception to that is aluminum. You know aluminum's a metal. you know that. If I said name a metal, aluminum's probably one of the first ones you're going to name. So we can now tell where the metals, nonmetals, and metalloids are. Oh, this would be blue. LV is blue. Although we'll probably never mention livermorium or whatever it is. Metallic properties. Metals lose electrons. So I know when you think of metals, you think of them being shiny and bendable and can turn into wires. But the most important thing for being a metal is they lose electrons when they react. Okay. Metals react with acids. Metals conduct electricity as solid and liquid. Okay. There's one other thing. Metals also reacted. We did this in our lab with CuCl2. So as far as our labs go, metals react. Non-metals do react, but as far as our labs go, it's that. Non-metal properties, non-metals gain electrons. That's the most important part. They're dull, boring. They're brittle. Yeah, they break and shatter when they're solids. They do not, it does not react with acids. It does not conduct electricity, which means it's an insulator. And a semi-metal, or also known as a metalloid, is a mix of each. So it might be dull, but reacts with acids, and that would be my second. I think that's it. Yes, it is. We're out of here in 6:15. To that I say, toodles.